Example 4 is another integrate with respect to y, and you are kind of stuck doing that unless you can learn how to integrate using cylindrical shells, which is not required on the AP exam, so I don't even cover that. But we can handle that using integration with respect to y. So I took the liberty of already drawing the border, or this region here. Y equals, I didn't fill that in though, y equals the square root of 2 minus x. I cheated a little bit here just to show you what you do when you don't remember the transformations that you learned in pre-calc honors. So just plot some points, and you could pretty much, well, you can tell what the points are. You can plot them along the way. 1, 1, 2, 0, 1, 1, then you get 0 radical 2, but so you know it's between 1 and 2, and then you get negative 2, comma 2. So you can usually get by with plotting a few points to get the general shape of the graph, and you know that a square root function has that general shape. So we're pretty close with that. And again, we're going to be rotating this around or about a line, and this again is a vertical line. So when you're rotating it about a vertical line, you know you're going to be integrating with respect to y. Okay? And so drawing one rectangle, or one vertical line, and it becomes a rectangle. There's our one rectangle. We know what the area of that rectangle is. We don't want that. We want the volume of the disk. So before we do that, we're going to reflect that image, that function right there about the line x equals negative 2. So that looks like that. Okay? And then we're going to go ahead and draw the disk. So if we rotate this rectangle around the line, x equals 2, comes down like that. That did not work out the way I wanted it to. Not too bad, but not great. And it comes back around here like this. I get sloppy at the front of it. As long as you get a general idea of what that disk is going to look like. They're all going to be, oh, that's horrible. Sorry guys, I let you down there. So anyway, we want to draw that disk over here to the right. Okay. We've got a radius. Now that's the hardest part right there, is finding that radius. Alright, so let's work on that. If we're integrating with respect to y, we can't just have this sitting here right here. This should be looking at you should be looking at this thinking, okay, I need to get x by itself and then some function of y. So we're going to take this equation and we're going to solve for x. All that stuff you've learned since you've been born is going to help you here in calculus. So we take the equation, y equals the square root of 2 minus x, and what do? Well, we got to get x by itself. To undo that x, we need to square both sides, and so we get y squared is equal to, when you square the square root drops off, and then we're going to do this. We're going to add x to both sides, so we get x on the left, and we're going to subtract y squared from both sides, so we're going to get x equals 2 minus y squared. So this curve right here has two names. Y is a function of x, and then x equaling 2 minus y squared. Okay, so we can call it either way. If we wanted to integrate with respect to x, we can find the area of that, but that's not going to help us. So now we know what that curve is. And don't forget, we want to find the radius of this disk, and the radius of the disk is the distance between the vertical line and that curve. Okay, depending on how high you are, that would be determined by y. That's why it's a function of y. So remember, the length of a horizontal line segment is the right-hand side minus the left-hand side. Okay? So the right-hand side, again, we just figured that out, is 2 minus y squared. Okay? Minus the left-hand side, meaning the left-hand function, or the left-hand value as a function of x, x equals negative 2. So we subtract negative 2. It's okay to do that. It's okay to subtract negative numbers. So we get 2 minus y squared, 2 minus y squared plus 2. So we get 4 minus y squared. That right there is our radius. That's our radius. Okay, so we know how to do this from here on out, right? We find the volume. To find the volume, we integrate, and don't forget, here's what we're doing. We're integrating with respect to y, and we're taking the bottommost disk. The bottommost disk would start at y equals 0. Okay, so y equals 0 is where the disks will start. They keep moving all the way up, and then where do they end? They end at the y coordinate of the highest point. And the y coordinate of the highest point, I actually got that already by plotting points to draw this graph. And the y coordinate of the highest point is 2. It's the y coordinate of that point of intersection right there. So 2 is the highest point, 0 is the lowest point. So we're going to integrate from 0 to 2. And we know that we need to integrate the volume of one disk, and we know the volume of one disk is pi r squared, which is the area of the base, multiplied by the height, or the width of the disk, however you want to think of that. So we get pi r squared times dy. And we already know that the radius is, because it's right above there, so 0 to 2 pi times the radius squared. Don't forget to square it. 4 minus y squared squared. Pi times the radius squared. If you force yourself to say that over and over again, you won't forget to put the squared there. I guarantee it. If you get sloppy here, you will forget that squared. It happens all the time. Because you see the squared here, so your mind wants to fill in. Oh, it's already there. But don't fall into that trap. Okay? So maybe pause the video, type that into your calculator, and see if you get what I'm going to show you here in just a moment. Okay? And decided to just show you how to do the calculations on the kind of like the older calculators that don't have the special symbols. And so just to clean this up, guys, I want to make sure you're aware why I'm doing this. Put it into y1, you'll make less mistakes as well. 4 minus y squared. Again, we're going to put x squared in there. 4 minus x squared squared. Okay, there's two squareds in there. That's the integrand. Every time, put your y1 as your integrand. You clean it up, you get to look at it carefully, and then make sure you make any adjustments. Quit that screen, and then go to your Math 9. Math 9, that's your bread and butter. FNINT, we're going to evaluate the definite integral of y1. So by now you should be getting pretty good at that. Comma x, comma, and then the limits of integration, 0 to 2. Go from 0 to 2, and you get 53.617. It's kind of cool, you know, when you punch all that stuff into your calculator, you get the exact value. That is the right answer. So we get 53.617. And you look for units of measure, and we don't have that, so there you go, 53.617. You'll have to do some of these by hand, but right now I just want you guys to focus on setting them up. And have a great night. So the next videos you'll see are the ones where I give you some practice problems, and I don't remember what page that, oh, I guess it's on the last page of these notes. So the notes are over. Now try the practice problems and check out the videos to see if you got them right. We'll see you guys on Monday. Well, I'll see some of you tomorrow.